Hello, pre-calculus students. So we are going to talk today about section 5 in chapter 6. So translating sine and cosine functions. So we talked before about amplitude and period changes. We're going to add to that translations or shifts left, right, up, or down. So the general form that we talked about before was we could have y equals a times the sine of b times x minus h plus k if it was a sine function, or we could have y equals a times the cosine of b times x minus h plus k if it was a cosine function. Okay, so remember, amplitude is the absolute value of a. That's telling you like how far up and down. Period we get by doing 2 pi over b. Phase shift is another way of saying our horizontal translation. We usually use this if it's a trig graph, we call it a phase shift. Okay, that's our h value. That's going to make it move left, right, up, or down. And then k is our vertical shift. And all this relates back to stuff that you did, back with other functions in previous classes. So you have seen before maybe an equation that looks like this. That's a parabola, right? And that minus 2 would mean you go to the right 2, and the plus 4 would mean that you go up 4. It's the same idea, except for that it's going to be with these trig functions. Okay, so for our first one, cosine of theta plus pi. So we want to think about for each of these, what's our amplitude, what's our period, what's our phase shift, just like we did before. Now this is a cosine function, so I'm comparing to this guy up here, and I'm trying to think, all right, what's my amplitude? So when I look at this equation, the amplitude is what's in front of the function, and here what I have in front of my function is just a 1. So my amplitude is 1. Okay, my period comes from doing 2 pi divided by b, and b is the value that is kind of out here. Now this is the first time we've seen it where maybe we're adding or subtracting. It's the number that's being multiplied by our variable. So if I wanted to, I could rewrite this. If I wanted to rewrite it in that form, it would be 1 times the cosine of 1 times theta plus pi, and then plus 0. So my period, my b value is 1. So it's as though there's a 1 right here. So this is 2 pi divided by 1, or 2 pi. Okay, my phase shift comes from the h value, and it's the opposite of what you would think. So if it says minus h, it's really that you go to the right h, and if it's plus, it's to the left. Okay, so this is plus pi right here. So that means we're going to go to the left pi. So our h value is negative pi. We're going to go to the left pi units. And then our vertical shift is what's being added on the end, which is our k value. And in this case, nothing is being added to the end, so it's as though my k value were 0. All right, so we're going to start how we did before, right? Last week we were talking about amplitude and period shifts and kind of starting with that, starting with the parent function, and then kind of going from there. We're going to do the same thing here. So this is a cosine. Remember our parent function for the cosine. So my parent function for the cosine is the one that starts up here at 1, then it hits the x-axis at pi over 2, hits its min at pi, x-axis again at 3 pi over 2, and then hits the end of its period at 2 pi. That's my parent function for cosine. That's what I'm dealing with right now. So basically, my amplitude is 1 and my period is 2 pi. That actually isn't changed for this one. What has changed is now it's being shifted to the left pi units. Okay, so it's like I want to think of this graph, but shifting pi units to the left. And there are a couple of different ways to come at this. Now, some of you in your head can say, oh, that's my parent function. And in your brain, you can just say, oh, I'm going to move everything to the left pi units. Not everybody's brain works that way. So I'll show you a couple of different ways that you can kind of approach these problems. One is to just sketch your parent function with, the amplitude and period on the graph. And then once you have that on there, then shift from there. And so that's what I'm going to do to start. So I'm going to start with thinking, okay, I'm pi over 2, and normally I kind of try to put that at the end, like say, okay, 2 pi is here, and I need to shift pi units to the left. If I end my cycle, my period at 2 pi, do I have room to do that? And I would, right? If this is here, is 2 pi, and I need to go to the left. I have room to the left. Now, if this was 2 pi, my period, and then I said go to the right pi units, my scale, I wouldn't have enough room to do that. I need to change my scale. And this one, I don't have to think about that yet. Okay, so I'm going to throw on my normal scale. And because I am not changing the amplitude and I'm not moving up or down, I'm going to just have my 1 be up here and my -1 down here. Okay, so I'm going to start by just really sketching my parent function on there. So basically taking these points and getting them onto this graph. Now that's not my final answer, so I am not going to fully draw this in. I'm going to draw this in just as a dashed curve because this is not my final answer. Okay. Feel free, you should pause, I think. If you're pause, make sure you have a scale down and then come back and do the drawing. Okay, so now my phase shift is -pi. So that means I need to go to the left pi units. Okay, on my scale right now, from 0 to pi, from here to here, is 4 spaces, is 4 little marks on my grid. So pi units is 4 spaces, and then I have to go to the left. So what I'm going to do is I'm going to take these 5 critical points, my max, my min, and my intercepts, and I'm going to shift them all 4 spaces to the left to get that phase shift. Now, if I also had a vertical shift at the same time, I would go the up or down. But in this case, I only have to shift everything 4 to the left. So I'm going to take this point here, and I'm going to go 1, 2, 3, 4, put my new point. And if it's helpful to you, you could do it in a different color. Okay, I'm going to take this intercept and count 1, 2, 3, 4 back. Mark it. This one's going to go 4 back. So they all go 4 back. This one goes 4 back and ends up landing on one of the previous points. That's why sometimes it's nice to have a separate color. 1, 2, 3, 4. Whoops, can I count 1, 2, 3, 4? Okay, there's my translated graph. And so now I can draw my cosine. Okay, and remember, this would curve down. So don't have it, shooting up because the cosine keeps going. If you wanted to do more cycles, you can, but I'll take 1 period. Okay, so now let's take a look at the next one. This is a sine. So we're going to think in our brain, okay, what does the parent function for the sine look like? That's the one that starts at the origin. So this is just my parent function from the sine that we talked about before. And let's compare this equation to my parent function so that y equals a sine b x minus h, or theta minus h plus k. Now, when you look at this one, you might say, it doesn't look quite the same because I'm noticing that in this one, the 4 is in the parentheses, not outside of the parentheses. So when I rewrite this, I want to rethink of it as y equals 1 times the sine of, I need that 4 on the outside of the parentheses. So it's almost like I'm pulling the 4 out as a greatest common factor, even though it's not really a factor of the pi. But I'm going to pull it out. So I have 4 times theta is 4 theta minus, now my h value is not going to be pi anymore. Now I need to think, okay, 4 times what would get me to pi? And if it helps, just jot that down off to the side. 4 times what would equal pi? Well, I need a pi in there, and I want these to cancel, so I would need pi over 4. What you could also do is just if you divide the pi by the 4, it'll work also. So this is pi over 4. And then it's like plus 0. There's nothing on the outside. Okay, so then from there, we can say, okay, our amplitude is the 1. My b value is 4. So my period is 2 pi over 4, or pi over 2. My phase shift is, my h is pi over 4. So that's pi over 4 to the right. And then I don't have a vertical shift. We'll get there in a minute. Okay, so my period is pi over 2. So again, here's my sketch, right? Well, the period is normally 2 pi. So I really want to rethink this whole thing with a period of pi over 2 instead of 2 pi. So I'm going to sketch that, I think, down here at the bottom. I have a little bit of room. So I'm going to resketch a plain empty sine, but my period is pi over 2. So it means it ends at pi over 2 instead of at 2 pi. And that means this is halfway. Halfway between 0 and a half pi is a quarter pi. Halfway between 0 and a quarter is an eighth. Okay, if you're not sure how I'm getting that, you could always say, okay, pi over 4 times half is what? That's pi over 8. So that makes this pi over 8. Sometimes I like to think my scale out before I put it on the grid. Okay, and then people are always like, well, how do I get this next one? Okay, well, now this is broken up in eighths. This is 1/8. This is 2/8, right, which reduces to pi over 4. This is now 3/8. So this is like 3 pi over 8. And that's 4/8, or 4 pi over, drop my pen, 4/8, which is 1/2 pi. Okay, and then my amplitude is 1. So if you want to do the whole sketch thing, you could start by sketching this on here and then translating it. The thing is, though, you have to think about your scale, because if you put the pi over 2 here, but then in this case, I have to go pi over 4 to the right, I'm not going to have enough room to do that, right? I can't say this is pi over 2 and halfway is 4 space. I don't have 4 spaces to go, right? So what I'm going to do instead, because this is kind of broken up, this is like 8 right here, I'm going to go halfway, 1, 2, 3, I'm going to go 4, and I'm going to say this is my pi over 2. And then this is my pi over 4. I'm not going to try to squish, or I guess I could. This is my pi over 8. It just gets hard to see, right? It gets really busy in here, and this is my 3 pi over 8. Okay, my amplitude is 1, and I'm not shifting it up or down, so I'm going to just throw my 1 here and here. And I'm going to start just by sketching my sine without regard to my phase shift. Now, if you think, okay, wait, hang on, I could just do this all in one shot, totally go for it, okay? Because pi over 4 to the right, okay, pi over 4 from 0 to pi over 4 is 2 units. So that means I have to go 2 units to the right. So I think it's helpful to have the sketch, but if you just have the sketch and you're like, okay, I just need to take all these points and go 2 to the right, you could go directly to your graph, right? I could take, I'm going to take 0, 0, but I have to go 2 to the right. That would put me at pi over 4. Okay, I'll do it this one that way. You don't have to. You could also draw this on here, right? I could sketch all these points and then do that. I'm going to go 2 to the right, 2 to the right, 2 to the right, and have them both. I'll do this one where I just use my sketch, but you could do it either way. Okay, so 0, 0, instead of being at 0, 0, I have to go 2 to the right. So I have to start at 0, 0, and then go 2 to the right. Okay, this next point would be pi over 8 and 1. So if I go to pi over 8, 1, but then I have to go 2 to the right. Okay, this point is at pi over 4, 0, but then I have to go 2 to the right. This point is at 3 pi over 8, negative 1, but then I have to go 2 to the right. And then this last one is at 1/2, 0, but then I have to go 2 to the right. I know it's really hard to see them all in there. Okay, so then I am going to sketch my curve. All right, so I think it helps to have a sketch with your amplitude and period on it, and then, sorry, I dropped my marker, and then go from there. Okay, so we're going to do a couple more. So this next one does have a vertical shift. So if we were to, I'm going to just write my general form for a sine here. Okay, and then I'm going to say, okay, well, what's my amplitude and all that? I'm going to rewrite it. If it's helpful to you, you can. You might not feel like you need to. So this is 3 times sine of, I don't see like parenthesis or anything. So it's like having 1 times theta minus 0, right? Because this would be just theta, and then times 1 would just be theta, and then plus 2. So my amplitude is 3. My period, my b value is 1, right? My b value is 1, so it's 2 pi over 1, or 2 pi. My phase shift is nothing, so that makes it easier. Phase shifts to me are the worst. They're like, because you have to think more about your scale than the rest of them. All right, and then 2 is your vertical shift. So now I've got a sine, normal period. Okay, nice. I don't have to think about my scale. That's awesome. But my amplitude is 3. It's stretched out, and it's moved up 2. So it's like I'm starting with my normal sine function here, but instead of this being a 1 now, it's a 3. And it's going to get moved up. So if in your head you're like, okay, I can see that it's going to get stretched out and moved up, and you can do that all in your head, go for it. Some people have a hard time visualizing it. Okay, and I will say probably I was one of those people back in the day. It helps me to have this little sketch. This is my normal sine, but I'm thinking, okay, that's 3 and that's negative 3, but that's still my 2 pi. And I'm not shifting it left or right. So yay, I'm going to leave that 2 pi, like just normal scale. Okay, this, you'll be dreaming about pi's in your sleep, not the good kind either. Okay, now I've got an amplitude in 3 and I've got to move up 2. So when I make my scale on my y, I'm just going to go by 1 so I can fit everything in. I'm going to go ahead with my sketch first and then I'll move it up. But again, if you feel like you can do both, totally fine. Okay, so my sketch of this would be, okay, start at the origin, then here, this is like the pi and the pi over 2, right? So at pi over 2, I'm up at 3 because that's my amplitude. And then at pi, I'm at 0. And here at my 3 pi over 2, I'm down at 1, 2, 3. And then at 2 pi, I'm back at 0. I'm going to do this just again dashed because it's not my official final answer. Okay, so now based on my scale, if it's a vertical shift of 2, I have to go 2 units up. So every single one of those points needs to go up 2 units. So I'll take this guy here, up 2 units, this guy up 2 units, this one is up 2 units, up 2 units, up 2 units, and there we go. Okay, so you see it's almost as though the x-axis is shifted up 2 units. Sometimes, and your book is going to refer to this sometimes, or like might be information might be given to you and say the midline is 2. That means like the shifted x-axis is that horizontal line 2. Okay, so let's take a look at this next one. So this next one, again, I'm going to think about, all right, is it in the correct form? Okay, so I've got this 2, okay, that's going to be my amplitude, but I noticed that theta over 4, that divided by 4 is in the parentheses, and so I don't know like my b values, and it's in the parentheses, it's going to screw up my h value. So it's like, well, I have to pull, this is like having 1/4 theta, so I have to pull that out as a GCF. And so then this is theta plus, okay, so now think 1/4 times what would get me to pi. So 1/4, because when I distribute this back out, 1/4 times this has to get me to pi. So I'm going to jot that down. 1/4 times what is going to get me to pi. All right, so you could think in your head, you could even do a quick little solve, multiply by 4. This has to be 4 pi. And then minus 1. So when you do that process, it should always be that if you distribute that back out, you end up with what you started. Okay, so now our amplitude is 2. Our period, well, my b value is 1/4. So it's 2 pi divided by 1/4, which is the same as 2 pi times 4 over 1. So my period is 8 pi. And I have a phase shift. If this is plus pi over 4, then it's negative, or not pi over 4, 4 pi. It's negative 4 pi, and I have a vertical shift of -1. Look, I've got everything. Isn't that exciting? Okay, so cosine. Here's my parent function for cosine. For these, I like to start out by thinking, all right, what would this look like with my new period and my new amplitude? Okay, so I'm just going to do a clean sketch over here, I think. Okay, so I'm going to sketch a cosine, which normally like hits here, 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 like goes like this. Right, normally this is at 2 pi, but now my period is 8 pi. So then here's halfway is 4 pi, and this would be 2 pi, and this would be 6 pi. No fractions, that's amazing. My amplitude is 2, so these would be 2 and -2. So I'm going to sketch that, and then I'm going to apply this phase shift. Now I do want to think about, okay, I'm shifting to the left. I have to make sure I have room. Normally to the left you have room because you end as far to the right as you can. It's when you go to the right that you have to think about it a little bit more. Okay, so if I were to make this 8 pi, would I have room to go to the left 4 pi? Sure. Okay, so nice. This is so easy now, right? This is just 8 pi, and this is 4 pi, and this is 2 pi. Not 3, 6. Okay, so then, I've got a vertical shift of 1, and I've got an amplitude of 2. So if some people are like, well, I'm going to go by 2, like I'm going to say every 2 spaces is 1, and you go off the graph a little bit, but you just have to be careful when you do that vertical shift. If you say that's 1 there, and you have to shift down -1, that means you're actually moving 2 spaces down, and sometimes people forget that, so just be careful. I am just going to stick to going by ones. All right, so I'm going to use this sketch here to get kind of my function, my parent function with the amplitude and period. You could like just use your sketch and then say, okay, I have to go to the left. Let's see, 4 pi on the scale is going to be left 4 and then down 1. And I'm going to do those at the same time. So if you want to do it that way, you can. I'm going to go ahead and just draw this, what I see here. So I see at 0, I'm up to 2. I see at 2 pi, I'm at 0. I see at 4 pi, I'm down to -2. I see at 6 pi, I'm at 0. And I see at 8 pi, I'm at 2. Okay, so this is, and I'm just again doing it dash because it's not my final answer. Okay, now I need to take each of those 5 points and shift them to the left 4 and down 1. Okay, so I'm going to go 1, 2, 3, 4, and I'm going to go down 1. And then this one's going to go 4 to the left, down 1, 4 to the left, down 1. So I'm doing that for all these. 4 to the left, and down 1, and then 1, 2, 3, 4 to the left, down 1. And then here is my graph, and you can see it still has the amplitude of 2, but it's been shifted. Okay? Some people find it helpful knowing that they have a vertical shift to just almost start out by saying, okay, I'm going to draw in my new midline, right? The new kind of center, vertical center of my graph. And then that helps me to see my amplitude of 2. Okay, example 5 is the same as example 1. So yay, we don't have to do it. Isn't that exciting? Okay, one more of these guys, and then we'll practice with writing equations. Okay, so you might want to pause this one and see if you can get it on your own. Okay, it's another cosine. Can I tell you that cosines aren't my favorite? I think sines are better. I don't even know why I have a preference for such a thing, but I do. Okay, so here is my parent function. I'm just going to rewrite it. You don't have to do this. Sometimes it helps. Okay, so nothing stuck on my theta, so it's really my b is 1. Really, I didn't need to rewrite this at all. Okay, my amplitude is 2. My period is 2 pi over 1, which is just 2 pi. Okay, that's kind of nice. My phase shift, this is plus pi over 2, so it's negative pi over 2 or left, and I'm going down 3. Okay, so then I'm thinking scale-wise, normally I end up 2 pi. I have to go to the left. Okay, I should have enough room to do that, so I'm sticking with my traditional scale. And okay, an amplitude of 2 and a vertical shift of -3. I'm just going by 1, so this all fits. And then, it might be helpful to sketch a cosine. Really, I have my cosine here, and I could just say, I'm going to tweak this a little bit, right? The amplitude is still 2, but it's just the period. This is just my regular old cosine, but with a different amplitude. So if it's helpful to you to sketch that and then do the shifting, do that. Or if you want to just go right from this and say, okay, pi over 2 is 2 units, so I have to go 2 to the left and 3 down. So you could say, okay, I have to start at 0, 2, and then from there, I have to go 2 to the left and 1, 2, 3 down. Okay, you could do it that way. I'm going to go ahead and put my new midline in, which would be that my x-axis shifted 1, 2, 3 down. So I'm going to just draw that in. Sometimes it's helpful to see that. You don't have to. Okay, then I could take my pi over 2 is normally at 0, and I could go 2 to the left and 1, 2, 3 down. Really, once you have that started, you could say, well, I know like the spacing is always even. And say, okay, well, I know the minimum has to be like, okay, I got to go 2 more spaces and then go 2 down because that's the amplitude. Do it that way or not, doesn't matter. Okay, this is normally at pi and -2. So then I have to go, what did I say? 2 to the left and 1, 2, 3 down. Okay, this is usually at 3 pi over 2. I go 2 to the left and 3 down. And then I'm usually at 2 pi 2. And I go 2 to the left and I go 3 down. And there is my graph. Isn't it beautiful? All right. Okay, so then the last thing that you'll be asked to do is if I give you information to write an equation, go the other way. So if I say write an equation for a cosine and I give you the amplitude, okay, I know that's the A value, and I give you the period. Well, I know 2 pi over b equals my period. So I don't know my b value, but I could figure it out, right? So I could think 2 pi divided by what would equal 2 pi. Okay, well, b is 1. All right, then my phase shift, I know that's my h, and my vertical shift, I know is my k. And it is a cosine. All right, so I'm going to plug all my stuff in, and then we're good to go. All right, so y equals 5 cosine of, well, b is 1, so it's just 1 times x or theta, whatever you prefer, pi over 8 in parentheses. So I don't really need this 1 here. If you have it there, it's not the end of the world, but you don't need it. And then plus k, so minus 2. Done. Now, because amplitude, remember, it could be flipped over. Like this could be positive or negative. You could have it flipped over and the same information. I don't know why I wrote positive, positive. But anyway, so if you put positive, negative there, fine. But it says write an equation. So if you didn't, that's also fine. Okay, next one, write an equation for a sine function with an amplitude of 7. All right, there's my a period of 3 pi. Okay, so my period, I know I get by doing 2 pi over b. So what's my b value? That's what I really need for my equation. So 2 pi over what equals 3 pi. So this one you might be looking at it and saying, I don't know, some funky fraction. If that's the case, that's totally fine. Solve that equation for b. You put the 3 pi over 1 and cross multiply. So you could say, all right, b times 3 pi equals 2 pi, and then divide by 3 pi, and say b is 2/3. All right, so there you've got your b. Phase shift is h, vertical shift is k. All right, let's put that into our equation. So it's y equals a, which we said was 7. And again, you could put plus or minus 7 times the sine of our b value, which we said was 2/3. And then in parentheses, x or theta minus my h value, which was pi, and then plus k, which was 7. And you're done. Okay, so that takes care of section 6.5. Can't find my mouse, guys. I'm trying to end this video. Have a great day. Where's my thing to end this? I don't know. Stop. Have a good day.